Hello and welcome to the vRealize Automation 7.0 Spotlight Features Overview and Demo. My name is Jad Al-Zain. I'm a Principal Architect in VMware's Cloud Management Business Unit, and today I'm going to talk about several of the key capabilities and features that were delivered as part of vRealize Automation 7.0. But first, let's talk about where vRealize Automation, also known as VRA, is positioned in the software-defined data center strategy. VRA is a core component to the cloud management platform, delivering end-to-end automation across the entire ecosystem, not just the VMware components. vRealize Automation brings governance, brings extensibility, and brings a total layer of abstraction of underlying virtualization and cloud provider platforms. VRA also sets the foundation for other tools in the cloud management platform, including operations and vRealize Business. Let's take a step back and discuss why automation is such a critical aspect of the modern data center. As you're aware, a dozen or so years ago, VMware and the virtualization platform vSphere changed the data center landscape. It allowed customers to virtualize their underlying infrastructure and deliver a virtualized platform to their applications and workloads, and drastically reduce the overall footprint of their data centers. And that provided immediate benefits to the business. And while virtualization and tools like vCenter provide a core management capability and the ability to simply right-click and deploy a virtual machine template, and in a matter of seconds or a couple of minutes have an exact replica of that machine, there's a lot of missing parts to the overall schema. First of all, what am I doing before the application is requested? What am I doing after and post-provisioning of that clone operation? What am I doing in flight? What about the different ecosystem components, the hardware vendors and partner tools that have to be touched with every request? And we also have to look at governance. We have to look at our policies. We have to look at all the people and processes in the way of providing a truly automated capability when we're just talking about basic virtualization. So enter vRealize Automation. VRA is designed to handle all the aspects of a request that leads to an application being built and deployed and delivered and lifecycle managed, but also all the different components and policies associated with that deployment. So cost visibility, governance and lifecycle management, day two operations, etc. And it allows the business to deliver a much more agile infrastructure that is designed to just happen as applications are requested and provisioned. The underlying infrastructure is totally abstracted, whether it's a public cloud or private on-prem vSphere or any of the platforms that are supported by VRA. And at request time, all of those pre, in-flight, and post-provisioning tasks per policy, per governance, under the control of the business and IT, are completely automated end-to-end. And while vRealize Automation provides pre, in-flight, and post-provisioning capability and end-to-end integration of the ecosystem, the latest version, vRealize Automation 7.0, really ups the ante and provides a set of key capabilities and innovations that broadens the scope of automation and service delivery. So let's jump right in and talk about some of those capabilities. First and foremost is the platform itself, the usability of the product, and the overall user experience. And with the user experience in mind, one of the key objectives for vRealize Automation 7 was to reduce the overall complexity and increase the time to value for our customers. And that starts with the architecture itself. And with that, we focused on reducing the overall footprint of a deployed, highly available vRealize Automation architecture. In vRealize Automation 6.x, a highly available deployment could go anywhere between 12 to 20 or more machines for the overall solution. This was not satisfactory for our customers, nor our objective of increasing time to value. So looking at some of the capabilities here, first stop was to take application services, which is an existing external service that was actually not highly available or not capable of being highly available, and bringing that on board into the appliance in the core as a core service. Next up were the vPostgres data stores. In 6.x, as you might know, those Postgres appliances have to go externally to become a highly available pair, and those were yet another pair of external services. Next up was vRealize Orchestrator. Same deal. vRealize Orchestrator in a highly available distributed install had to become an external highly available pair, and that resulted in 2 additional appliances. And then finally, the identity management. In vRealize Automation 6x, the SSO appliance was not highly available, was an external service, and for high availability, we had to leverage vCenter SSO and an HA pair. In vRealize Automation 7, all of these capabilities are provided, all the core services are provided in a single pair of virtual appliances with a single load balancer, a single certificate in most cases, and the ability to very rapidly deploy and go to market with the solution. So taking a broader view and incorporating the Windows dependencies, we're down to about a total of anywhere between 8 to 10, sometimes 12, depending on the scalability and distribution. Total machines, which is drastically less than the 6.x counterpart. In some cases, about 50% less machines. And less machines means better and easier manageability, less complexity, and management of things like the virtual IPs for the load balancers as well as the certificates becomes a lot more streamlined. And while the reduced architecture plays a significant role in driving the overall user experience, the next objective was to help our customers take all the complexity out of deploying the solution itself. And with that, we've introduced the deployment wizard. The deployment wizard prompts the administrator or the person installing the solution at first login after deploying a single virtual appliance. The deployment wizard gives you an option of a minimal deployment for POCs, pilots, non-production environments, where I simply have 2 machines for the solution to get deployed, or an enterprise production-ready deployment, where I've built a totally highly available end-to-end implementation of a production-ready instantiation of VRA 7. This has taken a significant amount of the complexity and the time and the resources out of implementing VRA. While the previous version in 6.x in a minimal deployment, for example, took a day or 2 and sometimes even a week to install, the wizard-based deployment has taken that number down to under an hour. And that includes configuring all the core services as well as building and configuring the prerequisites of the external Windows machines. And likewise with an enterprise deployment, what could be multiple weeks to deploy an end-to-end solution and all the associated clustered requirements and clustered services for a true HA infrastructure, the enterprise deployment in the wizard has now brought that down to a matter of hours. And for the Windows components, the wizard actually identifies those machines on the network and allows you to pick and choose where you want each of the services deployed to. And when we're done, we simply let the services start and log into the UI ready to configure our first tenant. And this Spotlight feature is sure to change the perception of VRA being overly complex to implement. The wizard just simply does it all for you. Moving right along, let's talk about the next Spotlight feature in VRA 7.0, and that's the VMware Identity Manager, also known as VIDM. VIDM replaces vCenter SSO as the core authentication provider in vRealize Automation 7. And that provides, out of the box, a significant amount of capability as far as authentication, authorization, and access controls go. First and foremost, VIDM is embedded into the core appliance. It's automatically clustered as part of the architecture during deployment and provide accelerated authentication services that leave SSO in the dust. Most importantly for a lot of our customers, VIDM brings in the ability to incorporate external authentication providers. So SAML 2.0 providers and other multi-factor and two-factor authentication providers. The VIDM admin UI is incorporated into the overall VRA UI and provides the ability to incorporate authentication services into a broader hybrid cloud management solution. For example, when VRA is delivering Amazon as a service to the enterprise, we can now proxy authentication into Amazon and incorporate the enterprise's Active Directory infrastructure so I can deliver Amazon to the masses. And with VIDM's policy management, we can create various policies that identify exactly which users and groups are going to be consumed per tenant. We could also build a policy for advanced features like access controls. And for example, I could have a user who's logging in to vRealize automation from the on-prem enterprise network and required to log in with their Active Directory credentials, for example. But if that same user were to go home and log in through the DMZ or any sort of remote access solution, I can now identify that user as a remote user and require them to use multi- or two-factor authentication. And another important feature is branding. VIDM now allows our customers to completely brand the login screen and the overall look and feel of vRealize Automation 7. Okay, now let's talk about unified service design, brought to you by the Converged Blueprint capability of vRealize Automation 7. So the Converged Blueprint is exactly what it sounds like. It's a single unified canvas to build all services for vRealize Automation 7, whether it's infrastructure as a service, platform services that incorporate applications and application authoring, all my network capabilities by incorporating NSX and some of the key functionalities there, as well as anything as a service, also known as X as a service, what used to be called the Advanced Service Designer. A single unified blueprint provides drag and drop functionality. It allows me to bind the individual systems, and external services such as application services have now been converged to also provide that drag and drop functionality. I'll spend a little more time on this in the demo. And the components library allows me to pick and choose which components I want to drag onto that canvas. My software components allows me to drag and drop any software builds I've incorporated into the overall solution. I'm also able to drag and drop existing IaaS blueprints. So in the use case where my IaaS administrators and my application architectures are two completely different people, I could have that IaaS admin build my services and then log in as an application architect and simply drag and drop those existing blueprints instead of being in the business of blueprint design itself. I'm just building the application. Again, I'll spend a little more time on this in the demo. And let's talk about that networking integration for one moment. vRealize Automation incorporates all the key features of NSX, including the logical switches, routers, firewalls, and the logical load balancers. Based on a policy, based on the canvas, and dragging and dropping these services right onto the canvas, and as well as consuming existing capability, we're able to build some of the most advanced application-centric network use cases right there in the canvas, and at request time build all the networking services required for that given application to a point where I have a completely micro-segmented app-centric solution. And finally, we can take all of that work we did in the unified blueprint and export it as human-readable infrastructure as code in YAML format. So I can define an entire blueprint. I can then use the cloud client or the API to export that blueprint in YAML format, which is exported as a zip file, pass it over to my buddies and say, hey, import this application and let me know what you think. We could also use the YAML to version the blueprints. So for example, I'd export it into YAML format, open up the text, make some modifications to the text, including the name, the resources, the networks, and any other component, including the software components that may be incorporated onto that blueprint. And then I can import that as a new version of that same application. Then I can publish it and provision it via catalog services. And last but not least, let's talk about extending vRealize automation. Lifecycle extensibility has always played a critical role in vRealize automation, past and present. In version 7.0, we've incorporated a new technology called the Event Broker, which allows me to extend VRA in ways never possible before, with the user experience in mind. There are several extensibility use cases we need to consider that are part of an application's lifecycle. So for example, when I request a machine, I need to be able to plug into external systems such as ServiceNow and create a ticket that can be updated throughout the build cycle and then closed when the machine's delivered. And for day 2 operations, these are all the operations I can perform on any given machine after it's provisioned. So for example, shut down, restart, reprovision, power off, power on. At any one of those states, I need to be able to, again, hook into external systems, external tasks, run some scripts or workflows, or notify somebody, add governance, and so on and so forth. And this gives me more visibility and more control than I've ever had before. And then finally, delivering anything as a service. I'm going to use some of the same logic here to be able to plug into my workflow infrastructure using vRealize Orchestrator, and through the X as a Service Designer, be able to leverage VRO workflows to build just about anything as a service. So for example, I could have a service that allows me to do employee onboarding, or delivering some external service that is not necessarily a machine or anything controlled by VMware for that matter, but be able to deliver that in a very automated fashion by leveraging vRealize Orchestrator and its workflows. So with a matter of clicks, I can take any workflow into the X as a Service Designer and then publish it, entitle it, and lifecycle manage it just like any machine. And then finally, I can create similar custom services as day 2 actions using the X as a Service Designer. So with the Event Broker and the X as a Service Designer, we build the code, we build the workflows, we consume them through the logic, and then we entitle, govern, and lifecycle manage each one of these services. The Event Broker is a new technology that is designed to replace the CDK extensibility requirements of previous versions. And it allows me to do this with very limited knowledge requirements in workflow creation or any other extensibility use cases. I'm not hacking code in this case. I'm actually building policies that I could use globally or defined per tenant or invoked, in very specific use cases based on the subscription policy. Okay, so let's jump into a spotlight demo. I'm going to go over all of these capabilities and spend some time talking about each one with a little more depth. Okay, let's jump right into this demo. First, I'm going to log into my customized login screen provided by VIDM. I also have the option of selecting an available authentication directory. In this case, it's an Active Directory domain called corp.local. Logging in takes us to our Home tab by default, where I can view and configure information portlets based on what's important to me, the logged in user. I also have the option of adding new portlets or changing the layout. But this demo is going to focus primarily on VRA 7's Spotlight features. So let's jump over to the Administration tab and take a look at our first feature, VIDM. All of VIDM settings are available in the Directories Management section. Here you could add authentication sources, for example, additional Active Directory domains, and determine things like sync frequency, the target Active Directory domain, which attributes will be collected, and finally, which groups and users will be synced from the directory into VIDM. This could also be filtered for maximum control. Next, an access policy can be created to filter access into VRA by attributes such as the source network, for example, where the user is logging in from, and also the login device, iPad versus laptop versus desktop. We could also determine which user attributes are synced from the directory to the local database by specifying them in the user attributes section. Now let's take a quick look at approval policies. VRA's dynamic governance engine that provides greater visibility, more control, and the ability to incorporate external systems as needed. Approval policies are configured by the policy type, which includes all of VRA's available catalog items, or it can be based on existing items, which can point to a specific component of a broader deployment, for example, a specific software item. The approval policy is then defined using a number of settings to align with an enterprise's requirements, or provide new capabilities never before possible. Once completed and published, approval policies are applied to catalog services, individual items, or even day 2 actions using entitlements. Let's head over to the Catalog tab and take a glimpse of the services available to the logged in user. Here you can see several service categories and associated services. These services are defined by the catalog administrator and available only when entitled to the specific business group within this tenant. The catalog view shows the finished product, but let's take a step back and explore how we got here. To create any service, whether it's basic infrastructure as a service, application authoring, apps that incorporate dynamic networking, or anything as a service known as X as a service, we always start in the Design tab. vRealize 7 introduces a completely revamped service authoring capability called the Converged Blueprint Designer, also known as CBP. The CBP provides a unified authoring experience, allowing for the design and integration of basic or even highly complex applications, including the ability to author and incorporate applications, networking and security services, and even external services using the X as a Service Designer, which can now be dragged and dropped right onto the canvas and bound to the other components. But before we can include applications in the canvas, we must first define what those applications are. So let's explore our software components library. Here you can see a number of applications that have been previously defined or imported into the software library. The library can include web services, databases, middleware, and just about any software script or config element using basic bash command or PowerShell scripts. Let's take a look at an example software component. In this case, Microsoft SQL Server, which is actually published among several other examples in VMware Solutions Exchange as a YAML package and easily imported into this VRA instance for customization and consumption. Each software component is configured with a unique name, auto-generated ID, and a detailed description. You could also select a container dependency, such as a generic machine or more specific parent object, to dynamically build software dependencies and an execution order. Once bound to a container, the object cannot be dragged and dropped onto any other component within the blueprint. You could also configure properties that can be passed to a software component during script execution. Here you can see a set of properties that identify installation repos and other variables specific to installing SQL. Properties also enable the application architect to allow consumers to modify specific settings at request time or to dynamically consume a configuration element from another component within the canvas. Next, we configure the actions that will execute at build time during various lifecycle stages: install, config, start, and uninstall. And here we can see that a PowerShell script is used to install SQL. The script can incorporate any desired properties defined in the previous step. This makes reusing existing software installation scripts incredibly straightforward, while also adding significant capability and dynamic configuration elements that have never been possible before. A quick review, and we're ready to publish this software component and immediately make it available for consumption. Previous versions of VRA introduced an industry-first technology that allows any workflow to be quickly delivered as an entitled, governed, and lifecycle managed service. This is called Anything as a Service, better known as XaaS or X as a Service. In VRA 7, we have taken this functionality up a notch by allowing any XaaS service to also be dragged and dropped right onto the Converged Blueprint canvas and bound to any other component within the canvas. This enables quick integration of external systems or any of the other X as a Service use cases. So let's create a blueprint and put these technologies to good use. I'll start by clicking New to create the new blueprint. Next, I'll name the blueprint and provide a useful description. The unique ID, again, is automatically generated. I can optionally set an archive value and lease policy. The archive period determines how long to hold on to a provisioned machine once its lease expired. This could also be renewed. Next up is networking. Selecting an available transport zone in the NSX settings tab allows us to quickly extend the power of NSX into this blueprint. This enables the use of NSX-backed dynamic networking services and app-centric security. And with a single mouse click, we can engage one of NSX's most powerful capabilities, total app isolation, also known as microsegmentation. Once you click OK, our new canvas appears, and we're ready to build out our multi-tier application. The components library shows us all the default components and services available within the canvas. In machine types, you can see all the supported out-of-the-box endpoints, including the newly revamped vCloud Air endpoint. I can drag and drop any of these onto the canvas to start building a service based on the associated platform. But what we do now largely depends on the use case, the desired outcome, and even the admin's persona. For example, if my primary role is the IaaS admin, I might want to build the core OS or foundational services that will be offered to my organization and application architects. But in this example, my role is the application architect, and my interest isn't in the IaaS basics or even worrying about the backend minutiae. It's more about the application itself. So I'll jump down to the blueprints category and drag any of the available blueprints right onto the canvas to start building my apps. So let's build my amazing new app. This app is based on Windows and will be composed of at least 2 Windows 2012 R2 servers with an IIS web frontend and a SQL backend. So I'm going to drag and drop a Windows 2012 R2 blueprint right onto the canvas and call this SQL. And then I'll drag another one for the web tier and call it web. Now let's add software from the software components library. For the web tier, I will need an IIS and .NET component. So we'll drag each of these software components to the web machine. And likewise for the database tier, I'm going to drag and drop my SQL software package and also .NET to the database tier. All right, this application is coming together. Now that we've got the application basics configured, it's time to incorporate networking. So let's go to the networking and security library. Here you can see all the available networking options that can be used by this blueprint. For starters, any traditional existing network collected by the endpoint inventory can be dragged and dropped right onto the canvas. For NSX environments, an existing security group, for example one that was created by my networking and security team, can also quickly be consumed. Or you can opt to leverage an on-demand security group, which creates a dynamic security group using a set of predefined policies at provisioning time. For load-balanced applications, an NSX-backed on-demand load balancer can be added to the canvas as well. And this will dynamically create the VIP, the appropriate number of legs, and the load balancing policy at provisioning time. NSX also enables dynamic networking options such as the on-demand NAT network or the on-demand routed network. For this use case, I'm going to leverage the on-demand routed network to dynamically create an NSX-backed network at provisioning time. So let's drag and drop the on-demand routed network right onto the canvas. I'm going to select an available routed profile and add the name and optional description. Okay, next up is security. Since I'm going to need to protect each of these tiers, I will also be dragging and dropping the existing security groups for each one of them. One for the database tier and one for the web tier. And now that services have been dragged to the canvas, I can bind each of the components to the desired network and security groups by selecting the component and modifying the networking and security settings. As you can see, as each service was bound to the component, the canvas builds a logical connector for convenient visual of the relationships and overall network topology. And finally, the web tier of this application is going to need to be load balanced. And since the number of web servers deployed will be up to the requester, the load balancer needs to dynamically configure the appropriate policy at provisioning time. NSX provides this for us with a simple drag and drop of the on-demand load balancer. Once dragged onto the canvas, I can select which component I want to load balance, as well as the component network in the case of multi-homing. I could also select the desired VIP network. And finally, the ports and protocols that will be load balanced, which could also be edited. Now that I've got a completed application with networks and services intact, I need one final adjustment to ensure the components are built in the order of dependency. For example, I need the database tier to be provisioned and online before I can configure my web app. Otherwise, all the components will be provisioned concurrently. To do this, I will simply click on the component binding hotspot and drag it to the appropriate dependencies. And in this case, I'll drag the IIS software component to the SQL Server component. And this could be much more broad or more granular depending on the desired outcome. And there you have it, a completed application that can now be published and entitled for consumption via the catalog. And it's portable. vRealize now supports exporting any blueprint in human-readable YAML format, also known as blueprint as code. Using the included cloud client or vRealize APIs, you could export and or import complete blueprint packages, including the software components, all the scripts, and all component properties as YAML. Next, we need to address what happens pre, in-flight, and post-provisioning and extend the automation to the broader ecosystem. And to do this, we'll tap into one of vRealize's greatest new technologies, the event broker. Extending vRealize and its services into the ecosystem is not a new concept. Extensibility is a critical function of cloud and machine lifecycle management. And while vRealize has delivered significant extensibility for quite some time now, it has generally been perceived as overly complex and often required an extended services engagement to meet the advanced business use cases. In vRealize 7, extensibility starts with creating a subscription, a policy that triggers a desired workflow based on a set of interesting events or configuration elements. A subscription can be created for each extensibility use case and can be a global policy or based on a very specific event or object. Let's walk through a very basic example. In this case, my IaaS admin would like a snapshot created for every production machine that is configured by vRealize. I would normally have to create snapshots manually, but now it can be done automatically and based on a specific set of guidelines. So let's build this policy. I'm going to click New to create my new subscription. Next, I can select the event topic that coincides with my use case. As you can see, there are several out-of-the-box topics that address a vast majority of the extensibility use cases, including approvals and the ability to incorporate external governance systems, for example ServiceNow, for approvals instead or alongside vRealize's built-in capability. I could also trigger extensibility based on configuration changes of a blueprint or business group. In this example, I'm going to use the machine provisioning topic, one of the more popular topics. Next, I can determine whether I want this policy to apply to all events or for a specific set of conditions. Since I only want snapshots for prod vSphere machines, and only after they've been delivered as built, I'm going to create a subscription based on a set of specific conditions, all of which should be present prior to triggering the workflow. So here I'll create a policy with the blueprint name that starts with prod, a machine type, a virtual machine, lifecycle state name, meaning when I'm going to trigger this policy during the machine's lifecycle. Set it for machine activated, which means this workflow will be triggered once the machine is delivered to the requester. And then a lifecycle state phase of post. And that should do it. Let's move on to the next step. I've determined the conditions, and now I have to determine which workflow will be triggered once I have a match. The event broker makes this incredibly easy by providing VRO workflow inventory right here in the UI. I can browse through the library and choose any workflow I'd like to pair with the subscription. In this case, I'm going to select the vCenter workflow called Create a Snapshot. Finally, I will name the subscription and provide a useful description. And once saved, I will publish the new subscription, which immediately activates it. And as a result, all new prod machines provisioned to vSphere will be automatically snapshotted behind the scenes. This was a very basic use case, but take a moment to think of all the possibilities. Whether I'm automating snapshots or building a much more sophisticated extensibility use case, I can quickly create a policy to trigger any number of workflows during any lifecycle state using a broad or very specific conditions and have it immediately enforced at a global level, all done from a centralized UI. And back to the catalog for another look of what we're ultimately delivering to the business. A set of services completely abstracted from any one platform, any one cloud, and delivered seamlessly to the consumer, and with more automation, governance, and control than ever before possible. All right, so thanks for hanging in there. This concludes this presentation and demo.